So like when I would go raining in my stomach, and I want to double Cody if I don't. Take a breath. I'll get dizzy just from that.
Okay guys, welcome back to, I have no idea what week this is of quarantine. When we left off, we were talking about conservation of energy. So this is a social distancing roller coaster. They are 6 feet apart. So let's say we start our roller coaster here at point A, okay? And we want it to go down to point B and up to point C. What is the problem with this situation? A roller coaster is starting at point A with a certain height, right? And so we've got H1. And there's a certain amount of potential energy set or left in that height, okay? And so I know that as the roller coaster goes down the hill from point A to point B, okay, it's going to turn that potential energy into kinetic energy. And then it's going to attempt to go back up this hill, but the problem is, when it reaches right about there, and I'm just generalizing here, okay, it's going to stop because it doesn't have enough potential energy over here when it first starts off to get back up to point C, which is actually, that's a higher location, right? So point C is higher. H2. Okay, so what does this equation look like? Well, we've seen it before, and that's basically the total energy, okay, which is the mechanical energy, is equal to the potential energy, which means that is mgh plus the kinetic energy, which is 1/2 mv squared, okay? And so these are exactly the same equations. We're just looking at symbols here, or we're looking at the use of variables here to go ahead and define our equation. So m is equal to mass, g is equal to 9.8 meters a second squared. I guess our mass is in kilograms, okay? H is equal to height in meters, okay? And then finally V is equal to velocity in meters a second, okay? And so that's kind of the key that we have here, is that the total energy of the system is going to be equal to the mass times the acceleration of gravity times the height, okay, so that's our potential energy, plus, if the object is moving, okay, 1/2 the mass of the object times the velocity of the object. So what we're going to do is we're going to be going through and we're going to work out a couple example problems. We're going to do it in this format. 6 problems, okay, I'm going to do the first one, okay, I'm going to ask you questions, then we're going to do the second one together, and then the final one, I'm going to make you do it. It's all going to be on Edpuzzle, which you're already on. And so let's get started. Trampoline, guys, on the trampoline wall ride. So if we have a wall in a trampoline, Jimmy's sitting up here at the top. And Jimmy weighs, or has a mass of, I think like 80 kilograms sounds good. 80 kilograms. He is standing 3 meters above the trampoline. And I want to find out how fast Jimmy is going to hit that trampoline, okay? So the idea here is Jimmy's going to go ahead and he's going to jump off and he's going to take all 80 kilograms of his mass over the course of 3 meters of free fall, and he's going to convert that 80 kilograms into what? Well, he converts it into velocity, right? And so we have these two equations here. So what I need to do is I'm going to first start off, since Jimmy's standing at rest at the top of the hill, or the box. Okay? that means that he is all potential energy right now. So he's all potential energy. And that means that I can calculate Jimmy's potential energy as he's standing on top of the box because he has no kinetic energy. And this is going to be really, so I know that ME is equal to, okay, that's mechanical energy, total of Jimmy's energy. We'll change that to JE. Jimmy's energy is equal to Jimmy's mass, which is, I said, 80 kilograms. It's going to be Jimmy's mass, which is 80 kilograms, times 9.8, put this in parentheses, okay, times Jimmy's height, which is 3 meters. Okay? And that roughly correlates to GH. Now, because Jimmy's not moving here, he's not falling yet, I don't have to actually calculate his kinetic energy. So that's going to go away because he doesn't have any yet. And turn the calculator on. So that's going to be 80 times 9.8 times 3. Okay? And Jimmy's energy, after doing a brief calculation on that, Jimmy's energy, JE, is equal to 2,352, and those are going to be joules. What's going to happen here is as Jimmy jumps off the wall ride and starts hurtling down towards the trampoline, he's going to take all that potential energy, all 2,352 joules of that energy, and he's going to take it and he's going to turn it into kinetic energy because he's going to use up his potential energy. So what that means is up here is potential energy max. Okay? And then down here by the trampoline is going to be kinetic energy max. And we have to consider that that's going to be just before he hits the trampoline. So Jimmy jumps off, maximum potential to maximum kinetic. I already know what his maximum potential is. So that means that his maximum potential is going to be converted into his maximum kinetic. And that means down here, right, PE equals 0. And kinetic energy is going to equal what? What's the kinetic energy at the base of his free fall? Okay, so the kinetic energy at the base of his free fall is going to be 2,352 joules. So what that means is, since I know Jimmy's energy is equal to 2,000, and I guess I'll write this out first. Down here, JE is equal to KE. That means that 2,352 joules is going to be equal to 1/2 Jimmy's mass. 80. What are we doing on time? Okay. 1/2 times 80. And it's 1/2 in the velocity. We don't know the velocity yet. That's actually what we're looking at. Okay, we're trying to figure out how fast Jimmy's going when he reaches the trampoline down there. So it's 2,352 joules is equal to 1/2 times Jimmy's mass times his velocity when he hits the ground. Well, if I'm asking the question, how fast will Jimmy hit the tramp? Okay. I want to go ahead and I want to calculate that velocity value. So this is the value that I'm going to go ahead and look for. First off, what I want to do is I want to go ahead and I want to make things as simple as possible. So we're going to multiply 1/2 times 8. Okay, well that's getting actually pretty simple now. Let's go ahead and we're going to take the 40 and move to this side. Okay, and I'm going to get 50.8. Oh, okay, we're getting close here. So 58.8 is equal to v squared. And at this point, we are really, really, really close to solving for knowing how fast Jimmy hit the trampoline. Because all we need to do is we need to take the, I'll write this into color. Hopefully it shows up on the can. we need to take the square root of both sides to get rid of the square value there. Second square root of 58.8. Okay, and then we get that number. Okay, that is 7.7. We'll just round that up. 7.7 meters a second. What I'm going to find is my velocity, Jimmy's velocity at the bottom here, is equal to 7.7 meters a second. Okay, so when you're looking at these multiple choice questions, make sure or keep in mind that I'm going to round up some of the time because we don't want to write out all those numbers. They're not significant figures. So let's go ahead, and I've got 2 more questions for you, and get it going.